we are looking at an idea called as prime factorization. The first thing is we need to recall the word prime and co-prime mainly. Prime is to do with a number is said to be prime if it has a factor of a number is prime if it has a factor of how many factors should it have? 2 factors only. Now, next word that we need to discuss is co-prime. Two numbers are said to be co-prime if, I'll take an example, 4 and 9. 4 and 9 is said to be co-prime. Why are they co-prime? Well, let's look at the factors of 4, that is numbers that can divide 4. So 1, 2 and 4. Numbers that can divide 9 is 1, 3 and 9. Now, why are they co-prime? They're clearly not prime numbers, right? 4 and 9 are not prime numbers, but why are they co-prime? Because only common number that can divide both the numbers is 1. Other than 1, there's no other common number that can divide 4 and 9. And so they are co-prime numbers. Now, my question to you guys is 440, actually this is 442 and 269. Are they co-prime? Are they co-prime? To help you guys, I have option 1 and option 2. So pause and think over, answer the question, are they co-prime? So as per the idea that we just discussed, right? So what do you think as per option 1 and option 2? Are there any numbers that is common to 442 and 269? Is there anything? So 2 is not over here. 221 is certainly not over here. And yeah, 17 is not over here. 37 is not over here. So clearly they look like there are no common numbers. So that's the conclusion that I can make. What about this? Here too, we don't have 13 anywhere, 17 anywhere, 34 anywhere, and 37 anywhere else. So here too, there are no common numbers. So what can we conclude? That they are not, so that they are co-prime, right? They look like co-prime numbers. Here too, what can we conclude? They look like co-prime numbers. What if I showed you this? What about now? There is 17 as the common number, right? 17 is common. So with this, what can you tell? Yes. Sorry, not yes. No, they are not co-prime. So when we looked at 1 and 2, they kind of looked like co-prime. But when we looked at 3, you can clearly see that 17 is a common number and so they are not co-prime. So if anything else other than 1 is a common factor for both the numbers, then it's not co-prime. So as per this, they are not co-prime. So a connecting question to you guys. So from all of this 1, 2 and 3 option, what can you conclude from above discussion between option 1, option 2 and option 3? What can you tell? So for me, what I am looking at is just because sometimes numbers are not matching, like over here and option 1 and option 2, does not mean that they are co-prime. So clearly options here or numbers here are not matching, but us concluding that they're co-prime is not a good idea. So that's the basic conclusion that I am able to come up with. So we can't just tell that two numbers are co-prime or not co-prime. Okay, not co-prime we can tell, but co-prime we can't tell. That they are co-prime, we can't just tell looking at the numbers. So what should we do? So the answer is option 1 and option 2 are incorrect because it only shows some factors. So here we are looking at only few factors. That is few numbers that can divide the given numbers, which might lead to a wrong conclusion about the common factor. While option 3 correctly identifies a common factor as 17, proving that the numbers are not co-prime. So option 3 gave us 17. So this shows that to truly determine if a number are co-prime, you need a way to find all common factors or to confirm that they are none. So we need to do a better job is what we are trying to conclude over here. To avoid missing crucial common factors like that happened in option 1 and option 2, mathematics use a powerful tool called as prime factorization. So to tell if the two numbers have any common factor, we use the concept of prime factorization. Every number greater than 1 can be written as a unique product of prime numbers. This breaking down of a number into its prime building block is called as prime factorization. I'll explain this way. See, 84. Okay, let me put not in prime factorized form. Okay, that's a subheading. See, 84, I can always write this as 2 into 42. This can also be written as 4 into 21. We can also write this as then 7 into 3, 7 into 12. So we can write it in so many ways, but all of this are not prime factorization. Why? Because 42 is not a prime number, 21 is not a prime number, 12 is not a prime number, even 4 is not a prime number over here. But 84 being written as 2 into 2 into 3 into 7, wherein all of these numbers are prime numbers. All of these numbers are prime numbers, makes it a prime factorized form. So whenever you have a given number, if you write it as a product of prime numbers, we said to have prime factorized it, or we have prime factorization. Okay, it's as simple as that. So I'll give you guys more example. So let's answer the question, is 56 and 63 co-prime numbers? So there are many ways to figure out if two numbers are co-prime and how to, what I mean is, there are many ways to write the factorized form of given set of numbers. I'll show you those methodology. For now, let me just write this numbers. That is, let me 2, 1, 8, 28. So this can be written as 2 into 14. 14 can be written as 2 into 7. So this is the prime factorized form of 54. And next we are looking at 63. So 63 can be written as 3 into 21. 21 can be written as 3 into 7. I hope I have this right. Yeah, 9 7s are 63. And yes, 8 7s are. Okay, so yeah, are they co-prime? Are these two numbers co-prime? No. As 7, as you can see, 7 is a common factor. Okay, so how do you get this expanded form? How did I do this? It's in another video, so we'll be looking at that. So guys, again, I'll just want to define prime factorization. Let me start off with prime numbers. Prime numbers are numbers which has only two factors. Co-prime numbers are two numbers. They need not be prime numbers per se, but between them there is no other factor than 1. Now, when you write any given two numbers, they can look like they are co-prime numbers. But the true picture will be available only if you prime factorize the numbers. That is, prime factorization is a process wherein we break down the given number into its prime building blocks. That is, numbers which is made up of only prime numbers. If you expand a given number with such that the product leads back to the number and the numbers are made up of prime numbers, it makes it, we said to have prime factorized it. Okay, so 84, I can write it in many ways, but this is the only prime factorized form. And all of this is right, it gives back 84, but they're not prime factorized. And last, 56 and 63, I was able to expand it in this manner, and we could see that 7 is a common factor, so they are not co-prime numbers to answer this question. But this is said to be, this two lines are said to be factorized form of 56 and 63. Okay, so you can pause, please do write this, and in the next set of videos, we'll learn few more things about prime factorization.